Hello everyone. This time we will talk about like terms. So our objective would just simply be to identify like terms. So question, do you like mangoes? So if that's a yes, if you're not aware, the most famous mango in the world is the Indian mango. But according to the Guinness Book of World Records, the sweetest mango is found in the Philippines. So this variety of mango is what most Filipinos call the manggang kalabaw or carabao mango. So let's try to have a problem related to mangoes. So let's say there are five Carabao mangoes and three Indian mangoes in each basket. So if there are X baskets, because we don't know the number of baskets, so we will just represent the number of baskets with an X. So how many mangoes are there in all? So the answer is 5x plus 3x. Because as you can see, we're talking about number of mangoes in total. So we're supposed to use an operation addition for that. Then if we don't know the number of baskets, we just have to multiply the 5 with the number of baskets because as mentioned in the problem, there are 5 Carabao mangoes in each of the baskets. So 5 times x. Same with the Indian mangoes. So there are 3 Indian mangoes in each of the basket. And we don't know the number of baskets, so we just multiply 3 by the x. So 3 times x. So 5x for the total number of Carabao mangoes, 3x for the number of Indian mangoes in each of the basket. So all in all, 5x plus 3x. So now, let's focus to the 5x and the 3x. So as I mentioned a while ago, 5x represents the number of Carabao mangoes, while the number of Indian mangoes would be represented by 3x. And the operation is plus to answer the question, how many mangoes are there in all? So what do you notice about the literal coefficient of our answer? So yes, that's correct. If you notice, the two terms here, separated by the plus, the first term has a literal coefficient which is an x. The second term has a literal coefficient which is an x as well. In other words, the two terms have the same literal coefficient. So what does it mean if they have the same literal coefficient? That means that these are what we call like terms. So let's try to observe the following examples for like and unlike terms. Okay, so now let's define like terms and unlike terms based from what we see here. So if you notice, 7a and negative 2a, they have the same literal coefficient which is a. Here, 5j and negative 8j, they have the same literal coefficient j. And here, both of them has x squared y as the literal coefficient. But how come the following are unlike terms? So when we use the word meaning not like terms. So first, you'll notice that this is A, this is B. They're not the same. J squared is not the same as J. The J here has an exponent 2. The J here has an exponent 1. Here, it's x squared y. The ones with the exponent 2 is the x. And the one with the exponent 2 here is the y. So they're not the same. So how do we define like terms and unlike terms now? So when we say like terms, these are terms that have the same literal coefficient. So when we say same literal coefficient, the terms have the same variables raised to the same power or exponent. Otherwise, they're called as unlike terms. In other books, you will also notice that instead of saying like terms, they might call it as similar terms. Or if it's unlike terms, that means it's the similar terms. But in our sessions, we would prefer like terms, okay? Like terms and unlike terms. So let us try to list the like terms from the given. So we have here 2x minus 5 plus 8x. So take note there are three terms because there's a minus in here and a plus. First term, second term, third term. So let us list down the like terms from our number 1. Okay, that's correct. It's 2x and 8x. The 5 here, or negative 5, is not is not it's not a term which is like with the others, because at the first place minus 5 doesn't have a variable at all. In other words, it's a constant term. Okay, and here they share the same literal coefficient, which is x. Now let's have number 2. 3x cubed minus 4x plus 5x cubed plus 7 minus 2x cubed minus 5. Okay, very good. The answers are 3x cubed, 5x cubed, and this one, you can think of it as positive or negative 2x cubed. Okay, so these are like terms because they share the same literal coefficient, which is x cubed. Okay, do we still have another answer? Yes, that's correct. We have another answer, which is 7 and the 5. You can think of it as a 5 or negative 5. But why is it that these are like terms? Because both terms are constant terms. They don't have variable at all. So those are like terms. So we have two sets of like terms, the ones with x cubed and our constant terms. Okay, let's have examples 3 and 4. Let's determine whether the given terms are like terms or not. So we have 7ab squared plus 6b squared a. Okay, is it a yes or a no? So it's a yes. It's a yes because, as you can see, despite the fact that a and b squared are not on the same order here, but the ones with the exponent 2 is the b, same here, and the a's in both terms has an exponent 1. So that means they're just the same. So these are like terms. How about number 4? 3xy minus 3x over y. Okay, that's correct. The answer is no. The reason why it's no, because the literal coefficient here is xy. And when the two variables are next to each other, that's multiplication if you don't see any operation between them. But here, it's x over y. In other words, this fraction bar is an indicator that the operation is a division. So this is x divided by y. So they're not the same. So the answer is no.